Welcome friends to my YouTube channel Sommo Physics. On my previous lecture I shall told about the differential equation of the orbit. Now in today's video I will discuss about the artificial satellite and natural satellites. Now we all know that satellite are the bodies or objects that are rotating around another object. A satellite is an object which is rotating around another object. Okay, and we also know that there are two type of satellites. One is natural and another is artificial. So first, natural. These satellites are created by the nature. For example, if we take Earth, it has one natural satellite, that is moon. And if we take another example, we can write that Saturn. If we consider Saturn, then the Saturn has 18 moons. These are also natural satellites. Okay, if we take Saturn, then it has 18 moons. So these are the natural satellites. Now what are artificial satellites? Now if an object is hurled into the space with the help of a rocket so that it begins circling around the earth, it is called artificial satellite of earth. Okay, if an object is hurled into the space with the help of a rocket so that it begins circling around the earth, it is called artificial satellite of earth. Okay, so if an object is hurled into the space with the help of a rocket so that it begins circling round the earth, then it is called artificial satellite. Then it is called artificial satellite of earth. Artificial satellite of earth. Okay, so this is the definition. So in that case, the object must be hurled into the space with the help of a rocket so that it begins circling around the earth. That is, it must be rotating around the earth. So there must be a particular orbital velocity of the artificial satellite which we have to find out. Our next task is to find out the orbital velocity of the satellite revolving around the earth. Okay, and how we calculate it, let's proceed. So if we draw a picture, then this is simply the earth. Okay, this is simply the earth. So this is the radius of earth and that height is h, and the satellite is located at a height h from earth's surface. Okay, if we consider a artificial satellite of mass small m, then it is located at a height h from earth's surface. Okay, now what will be the force of attraction between the satellite and the earth? What will be the force of attraction? We all know the force of attraction will be G into capital M, that is mass of earth, into small m by the total distance, that is r plus h, the whole square. This is the force of attraction between the satellite and the earth. Now since the satellite is rotating around the earth, for any circular motion there must be a centrifugal force. Okay, the fictitious force, centrifugal force. For any circular motion there must be a centrifugal force. So what will be the expression of this centrifugal force due to the rotation of the satellite? This centrifugal force will be m into v square by r plus a. So what is v? V is the orbital velocity of the satellite. Now we all know that the stability condition will take place if these two forces are equal, then the system will be stable. Okay, so what is the stability condition? The stability condition we all know the stability condition. What is that? The stability condition is that fa equal to fc, and if we simplify it, what we get? m into v square by r plus h, this equals to g into m by r plus h tar whole square. So what we can write? We can write v square, this is simply g into m by r plus h. Okay, this we can write. Now we all know an important relation, that is acceleration due to gravity g, that can be written as g into capital M by r square, that is at the surface of earth. At the surface of earth we can write small g equal to capital Gm by r square. Now instead of Gm we can write small g into r square by r plus h. Okay, so what will be my v? My v will be r into square root of g by r plus h, r into square root of g by r plus h. So this is the expression of orbital velocity of artificial satellite. Okay, now another thing, we have to find out the time period of revolution of the satellite. And what will be it? What will be the time period of revolution of the satellite? We all know if capital T is the time period of revolution of the satellite, then it will be what? 2 pi into r. R means r plus h by its velocity. Now if we put the value of v, then we will get 2 pi by r square root of r plus h tar whole cube by g. Okay, now this is 2 pi by r, and this can be written as small r cube. Okay, that means we take small r, this is equal to capital R plus h. Okay, so this is the expression of time period of revolution of an artificial satellite revolving around the earth. Now if we take square on both sides, then what we get? Then we get 4 pi square by r square into r cube by g. Now there pi, capital R, that is radius of earth, small g, these are all constant, so we can write t square proportional to r cube. So clearly we see that artificial satellite obey Kepler's third law. Okay, artificial satellite obeys Kepler's third law. Okay, so till now we have calculated the velocity and time period of revolution of a satellite revolving around the earth. Now there is a special case. What would happen if the satellite is very close to earth's surface? So if the satellite is very close to earth's surface, very close to earth's surface, then h, that is the distance between the surface of earth and the satellite will become very small, and in that particular case we can write r plus h almost equal to r. Okay, so if the satellite is very close to earth's surface, then we can write r plus h, this is almost equal to r. So if we put that condition in the expression of velocity, then we will find out the orbital velocity in that particular case. So in that particular case, what will be my orbital velocity? R root g by r plus h. So almost equal to r root g by r. So this we can write as g into small r. Okay. So this is the orbital velocity in that particular case when the satellite is very close to Earth's surface. Now, if we put this condition in the expression of time period of revolution, then what would become? That is 2 pi by r into square root of r plus h whole cube by g. So that we almost write twice pi by r into root over r cube by g. So we can get 2 pi square root r by g. So this is the time period of revolution and the orbital velocity of the satellite when the satellite is very close to Earth's surface. And remember, these two are very important expressions and they are used in different portions of classical mechanics. Okay, this is a very important expression, and this is t equal to 2 pi square root r by g. Okay, so in today's video I discuss about the definition of natural and artificial satellite, and we find the orbital velocity and time period of a satellite revolving around the earth, obviously artificial satellite, and we also discuss about the case when the artificial satellite is very close to earth's surface. Okay, now if you don't subscribe my channel, then kindly subscribe it and share it to your friends, and also press the bell icon to get latest updated videos. Okay, thank you.